Good day, class. In this lesson, we will learn to solve rational equations. Remember, when we were learning to simplify rational expressions, we simply had an expression and we were making that expression more simple. Now we're using the knowledge and skill to solve, for example, a rational equation such as you see here. And it's simply an equation that has fractions, numerators and denominators, oftentimes involving polynomials. So starting with this really basic example, we're given 5/7 plus 1/3 is equal to 1 over x. And so that's not too bad, but we just do want to call back the rules for adding fractions, particularly those with unlike denominators. And so we'll combine those fractions. 5/7 plus 1/3 is 5/7 plus 1/3 is 22 over 21. I strongly recommend you to pop that in your calculator. If you're confident about how to add fractions by hand, then I recommend you follow the calculator tips provided to you by your instructor to simplify this fraction or to add these fractions and make your life simpler. It will save time down the road. Once we are looking at 22 over 21 is equal to 1 over x, well, there's just one unknown value here, or we simply have a proportion. If you recall the rules for dealing with proportions, you know that you can cross multiply. So with respect to cross multiplying, we're looking at 22x is equal to 21 because we're multiplying 22 times that x and that 21 times that 1. This leaves us with a basic equation, multiplication division equation. We like those. We're always trying to get back to the basic equations with which we learned about several years ago. If we divide both sides by 22, we end up with x is equal to 21 over 22. That cannot reduce further. In this example, we're dealing with more polynomials, so it's showing up a bit more, and we're asked to solve this equation. And so we borrow the same principles for adding, subtracting, multiplying, and dividing with fractions. And so the first move I'm going to make is to try to simplify some of these fractions that I have. Remember the rules for subtracting fractions with unlike denominators. So if you recall the pattern for dealing with that whenever we have polynomials rather than just plain old constant values, then you might notice the pattern here where I simply multiply my denominators to come up with that common denominator, and then I dealt with my numerators according to the pattern that you can see here. So if you don't remember that pattern, be sure to pause this video and take a look. The next thing I did was simplify what I have. So once I was able to combine those fractions on the left hand side, then I can, and on the right hand side, then I can simplify them both. And here's what you have. On the left I have 49y minus 18, and then on the denominator I have 98y. On the right I ended up with 336y minus 49 on the numerator and 686y on the denominator. So what I'm thinking is that 336, that 686 is making me a little bit uncomfortable, so I'm going to search for anything that I can to try to reduce that. What number might potentially divide into all of those numbers, 336, 49, and 686, to reduce it? And I discovered that 7 actually divides evenly into each of those. Wasn't able to find anything that divides evenly into the fraction on the left. So what I'll do with that one is just leave it like it is. But the good news is notice how that 98y turned up as a common denominator. For that reason, I'm going to go forward with trying to subtract these fractions because now they have, or combine these fractions I should say, because now they have like denominators. So notice what I did. I just took that 48y minus 7 divided by 98y and I subtracted it on both sides of the equation, leaving me with what you have here. Now I can deal with these fractions by simply subtracting the numerator because that denominator is a common denominator, so I can go ahead and just deal with numerators. So notice how I deal with that numerator very carefully, however, because we are subtracting, so we want to subtract that entire numerator, that quantity of 48y minus 7. This technique or this tool, the need to subtract very carefully and with these set of parentheses is very common, so always be on the lookout for that. And then as we proceed, we can just sort of simplify that numerator. We're getting back to the basics here, so we've kind of eliminated as much convolution as we can. Now we're just dealing with simple combining like terms in that numerator, so I go ahead and do that and discover I'm just left with y minus 11. and once I combine my like terms. And then I know that I can always deal with that denominator. I want to get rid of that denominator if at all possible. And so I multiply it on both sides, and you'll discover that once it multiplies by that 0 over there, it'll cancel if it multiplies on the left, when it multiplies on the left, and when it multiplies on the right, it multiplies by that 0, of course, leaving us with a 0, because anything multiplying by a 0 will get rid of it. So will become 0. So now we just have y equals y minus 11 is equal to 0, which of course resolves to y is equal to 11. Be sure to take this solution and substitute it back into your original equation to make sure that if y gets multiplied by that 49 in the original equation, 11 gets multiplied by that 49 in the denominator of the original equation, and also by that 14 in the denominator of the original equation, that you get a true statement on both sides of the equation. This can be done very quickly with your calculator, so I highly recommend that you be in the habit of substituting back your solution whenever you're solving equations to ensure that you have the correct answer. In this example, you're given p plus 5p is equal to negative 6. So I wanted to point out that you can use that understood denominator of 1 whenever needed. Be in the habit of looking to use that understood denominator of 1 if you need help sort of reconciling how to deal with the addition or subtraction of fractions with unlike denominators. So anytime a whole number has a p, for example, would be whole, and we're trying to combine it with the numerator denominator number, a rational number, we definitely want to create a rational, demonstrate that that number is also rational, p over 1. So then I can add those fractions as I see fit. And so now I'm following the same pattern on the left. Nothing's really happening on the right as yet. That negative 6 is just coming with us because I'm trying to deal with the left, trying to add those fractions. And so I follow that same pattern I talked about, and I simplify. And so on the left, I end up with p squared plus 5 divided by p. And so whenever that second power appears, I'm thinking quadratic. And I know how to deal with quadratic expressions and even quadratic equations. So I go ahead and try to create one out of this, or create one that's more familiar. And I'll multiply that p on both sides of the equation. Of course, it cancels on the left, but on the right, it ends up multiplying by the negative 6. And so now I can pull that negative 6 over p over to the left with the rest of the equation, sort of put it in descending order. And this is very familiar. P squared plus 6p plus 5 is equal to 0. And so I'm familiar with factoring when it comes to trying to deal with quadratic equations, quadratic expressions even. I want to factor this. And so I can factor this into p plus 1 times p plus 5, because if I were to multiply that back out, I'd end up with p squared plus 6p plus 5. So I like that because that gets me back to a couple of very basic linear equations. P plus 1 is equal to 0, and p plus 5 is equal to 0. And so now I can simplify both of those, or solve both of those basic linear equations, and discover that p is equal to negative 1 and p is equal to negative 5. I cannot emphasize enough how important it is to substitute back your answers into the original equation to double check to see, are these solutions to the original equation? Is this a fair representation of the value of p in this equation? And so I'll do that. I can quickly knock that down in my calculator if I'm familiar with the calculator and how to do that if I've been practicing along the way. So make sure you practice substituting your solutions back into your original equation.